Natural language processing, NLP, is a field of artificial intelligence that focuses on the interaction between computers and humans through natural language. The ultimate goal of NLP is to enable computers to understand, interpret, and generate human language in a way that is both meaningful and useful. This involves a range of tasks, from speech recognition and sentiment analysis to machine translation and question answering. In this presentation, we will delve into the creation of a question-answering QA project, exploring the various components and steps involved in implementing such a solution. Question-answering QA is a subfield of NLP that focuses on building systems capable of answering questions posed by humans in natural language. QA systems can be designed to handle a wide range of question types, from fact-based queries to more complex, open-ended questions. These systems typically rely on large datasets and sophisticated algorithms to understand the context of a question and retrieve the most relevant information. In this presentation, we will explore the key components of a QA system, including data preprocessing, model selection, and evaluation metrics. Before diving into the technical aspects of a QA project, it is crucial to define the scope of the project. This involves identifying the target audience, the types of questions the system will handle, and the sources of information it will use. For example, a QA system designed for customer support might focus on answering frequently asked questions using a company's knowledge base. On the other hand, a QA system for academic research might need to handle more complex queries and access a wider range of sources. Clearly defining the project scope will help guide the development process and ensure that the final product meets the intended goals. Data is the backbone of any QA system. The first step in building a QA project is to collect a large and diverse dataset that covers the range of questions the system is expected to handle. This dataset can come from various sources, such as websites, databases, and documents. Once the data is collected, it needs to be preprocessed to ensure it is clean and structured. This involves tasks such as tokenization, removing stop words, and normalizing text. Preprocessing is a critical step as it directly impacts the performance of the QA system. Selecting the right model is a crucial step in building a QA system. There are various models available, ranging from traditional machine learning algorithms to advanced deep learning models. For instance, transformer-based models like BERT and GPT-3 have shown remarkable performance in QA tasks. The choice of model depends on factors such as the complexity of the questions, the size of the dataset, and the computational resources available. It is essential to experiment with different models and fine-tune them to achieve the best results for your specific use case. Once the model is selected, the next step is to train it using the preprocessed dataset. Training involves feeding the model with input data and adjusting its parameters to minimize the error in its predictions. This process can be computationally intensive and may require specialized hardware such as GPUs. During training, it is important to monitor the model's performance and make adjustments as needed. Techniques such as cross-validation and hyperparameter tuning can help improve the model's accuracy and generalization capabilities. After training the model, it is essential to evaluate its performance to ensure it meets the desired criteria. This involves testing the model on a separate validation dataset and measuring its accuracy, precision, recall, and F1 score. Evaluation metrics provide insights into how well the model is performing and highlight areas that may need improvement. It is also important to conduct error analysis to understand the types of questions the model struggles with and make necessary adjustments. Continuous evaluation and iteration are key to building a robust QA system. With a trained and evaluated model, the next step is to implement the QA system. This involves integrating the model into a user-friendly interface that allows users to input questions and receive answers. The implementation can be done using various frameworks and tools, such as Flask or Django for web applications, or mobile development platforms for mobile apps. It is important to ensure that the system is scalable and can handle multiple queries simultaneously. Additionally, implementing features such as logging and monitoring can help track the system's performance and identify any issues that may arise. Deploying the QA system involves making it accessible to end users. This can be done by hosting the system on a cloud platform such as AWS, Azure, or Google Cloud. Deployment also involves setting up the necessary infrastructure, such as load balancers and databases, to ensure the system can handle high traffic and provide quick responses. Security measures should also be implemented to protect user data and prevent unauthorized access. Once deployed, it is important to continuously monitor the system's performance and make updates as needed to maintain its efficiency and accuracy. User feedback is crucial for the continuous improvement of a QA system. After deployment, it is important to gather feedback from users to understand their experience and identify any issues they may encounter. This feedback can be collected through surveys, user testing sessions, or direct interactions. Analyzing this feedback helps identify areas for improvement and guides future iterations of the system. Regular updates and enhancements based on user feedback ensure that the QA system remains relevant and effective in meeting users' needs. Building a QA system comes with its own set of challenges and considerations. One of the main challenges is ensuring the system can handle a wide range of questions and provide accurate answers. This requires a diverse and comprehensive data set, as well as a robust model. Another challenge is maintaining the system's performance over time, as language and user needs evolve. It is also important to consider ethical issues, such as bias in the data and model, and ensure the system is fair and unbiased. Addressing these challenges is crucial for the success of the QA project. The field of QA systems is constantly evolving, with new trends and advancements emerging regularly. One of the key trends is the use of more advanced deep learning models, such as transformers, which have shown significant improvements in QA performance. Another trend is the integration of QA systems with other technologies, such as voice assistants and chatbots, to provide more interactive and user-friendly experiences. Additionally, there is a growing focus on making QA systems more explainable and transparent to build trust with users. Keeping up with these trends is important for staying ahead in the field of QA systems. Creating a question-answering project involves a series of steps, from defining the project's scope and collecting data to training the model and deploying the system. Each step is crucial for building a robust and effective QA system. By following best practices and continuously iterating based on user feedback, it is possible to create a system that meets users' needs and provides accurate and relevant answers. As the field of QA systems continues to evolve, staying updated with the latest trends and advancements will be key to maintaining the system's performance and relevance. The next steps involve applying these concepts to your own QA project and continuously improving it based on real-world usage and feedback.